which bore greener surroundings and idyllic settings for the honing of talent, attitudes and skills. The engineering faculty was shifted to Peradeniya in 1964. Since then, under the patronage of many noteworthy successors, the island's oldest university has developed today as the largest, most renowned and most comprehensive centre for higher learning in Sri Lanka. University of Peradeniya strives to offer globally recognized knowledge and education to knowledge, secret and postgraduate levels, while fulfilling many national educational needs at several other levels. The university values academic freedom and cultural diversity, while endeavouring to provide the highest standards of teaching, training, learning and research. It hosts 9 faculties with an undergraduate student population of nearly 11,000, with over 1,500 registered postgraduate students. Peradeniya, being a residential university, provides on-campus accommodation to over 60% of its undergraduate students. At its inception in 1950, the engineering faculty consisted of just 3 departments of study: civil engineering, electrical engineering and mechanical engineering. Steady expansion and diversification of the faculty have taken place since the move to Peradeniya, and there are now 8 departments of study: civil engineering, electrical and electronic engineering, mechanical engineering, engineering mathematics, manufacturing and industrial engineering, chemical and process engineering, mechanical engineering, computer engineering, engineering mathematics, engineering management, manufacturing and industrial engineering, chemical and process engineering, mechanical engineering, computer engineering, engineering mathematics, engineering management, manufacturing and industrial engineering, chemical and process engineering, mechanical engineering, computer engineering, engineering mathematics, engineering management, manufacturing and industrial engineering, chemical and process engineering, mechanical engineering, engineering mathematics, manufacturing and industrial. A good balance between sound theoretical knowledge and industrial exposure. Furthermore, in aid of career and professional development of young engineers and technical staff of the industry, the faculty conducts many diploma-level courses with the participation of experts from all over the world. Unparalleled opportunities within a diverse culture and intellectual climate provides one of the best opportunities to become a well-rounded engineering graduate with a world-acclaimed engineering degree. Many renowned professional engineers in Sri Lanka and based around the world can attest to the quality and standards maintained at the faculty.
cable output कर microphone में डाल रखी है।
Formed in September 1991 under the guidance of former Dean Emeritus Professor M.P. Ranavira, PEFAA is the alumni association of the Peradeniya Engineering Faculty with a membership of around 5,000. PEFAA is the first faculty-level alumni association in the country and is a government-registered charity organization. Its main objectives are to encourage, foster and promote close relations between the faculty and its alumni and among alumni, financially and otherwise. The faculty and its students and alumni. helping students in their activities. In the recent past, PEFAA has been involved in administering a number of scholarships to undergraduates granted by alumni. PEFAA also makes awards established in the names of distinguished past staff members and also felicitates alumni who have rendered yeoman service to the faculty and the country. It also helps the undergraduates through orientation programs and by organizing lectures and seminars on industry-related topics. PEFAA supports industrial training of undergraduates and collects material for the faculty library and laboratories through its members. PEFAA is also involved in the refurbishment of lecture rooms and seminar halls, coordination of donation of the latest books to them. PEFAA recently started a project to provide a Wi-Fi-enabled synchronized clock system to the university. At the 26th Annual General Meeting of PEFAA, which was held on 2nd December 2017, it was determined to form the PEFAA Colombo chapter. The main objective of the Colombo chapter was to get engineers who graduated from Peradeniya and then University of Ceylon to get involved in PEFAA activities effectively. The Colombo chapter was ceremonially formed at Cinnamon Grand Hotel on September 27, 2018 with over 400 alumni participating. Another objective was to guide and assist alumni who have recently completed their course of study at the faculty to obtain employment and to engage in productive pursuits that are beneficial to society, thereby bridging the gap between the industry, academics and students. Bus project. One of the biggest monetary projects done by PEFAA is a 42-seater, fully equipped AC bus purchased for the faculty in the year 2015.
My God. Emang itu udah.
Very good afternoon, ladies and gentlemen. I would very much like to welcome you all to the third talk organized by Peradeniya Engineering Faculty Alumni Association. So this is another successful event organized by Peradeniya Engineering Faculty Association. So today we have a distinguished guest with us. We will be talking about mainly the product engineering at Vega Innovations. So to talk about it, we will have talked about like wide variety of in areas like supercars, EV charging to agriculture technology. For this event, I welcome to present this Dr. Beshan Kulapala, the director and co-founder of Vega Innovations, is with us today evening to enlighten you on this very interesting topic. So today we have wide variation of audience. Part of our audience is joining through Zoom platform. Part is joining through our Event TV Plus, that is a POTV channel 120. And we are also live streaming this event through PEFAA official YouTube channel. I would first like to welcome Dr. Beshan. Very good afternoon. And to welcome our guest and our audience. First of all, I would like to kindly invite the president of Peradeniya Engineering Faculty Alumni Association, Engineer Gamunu Ranasinghe, to deliver the welcome address. Over to you.
Thank you, Samit. Good afternoon, all. This is another knowledge sharing session organized by PEFAA. PEFAA, Peradeniya Engineering Faculty Alumni Association, which was established in 1991, exactly 30 years ago, is the first alumni association established at a faculty in Sri Lanka. I warmly welcome our guest speaker, Dr. Beshan Kulapala, to share the experience on his innovations. I would like to welcome all of you join online as well as through Event TV. I'm very glad to inform that YouTube live streaming of PEFAA Talk series is commenced from today. I must thank the management of POTV and Event TV for allocating their valuable airtime to broadcast these presentations on live. Thank you very much and have a good day. Over to Samit.
Yes, thank you very much, Engineer Gamunu Ranasinghe. So before moving to our regular event, so we are the PEFAA is very saddened to announce the dismissals of our great teacher and administrator, the Professor CLV Jayathilaka, a few days ago due to COVID-19. And I cordially invite the engineer Saras Seniviratne, the former head of the Department of Mechanical Engineering of University Peradeniya, to deliver a condolence note on Professor Jayathilaka. So over to you.
Thank you. And Professor CLV Jayathilaka, and he has been at the faculty and the university for quite some time. And of course, we are extremely saddened by the news of the demise of Professor CLV Jayathilaka, a fellow of the Institute of Engineers, Sri Lanka, who succumbed to COVID-19 a few days ago. He has impacted the lives of many in this country as well as around the world. Within the short time allocated, I will give a brief summary of his eventful life. After graduating with a first-class honors degree in engineering from the University of Ceylon in 1960, he joined the staff and proceeded to London for postgraduate studies. After obtaining the postgraduate diploma and PhD from the Imperial College, the prestigious Imperial College, London. He returned to Ceylon in 1966 and started working at the Faculty of Engineering, then shifted to Peradeniya. The Spalding Jayatilaka P function for the sublayer was a much used formula in the boundary layer analysis during the years that followed Professor Jayatilaka's this research. He was awarded the prestigious Unwin Prize for his PhD thesis. In my first year, he was teaching engineering drawing to our batch, and this particular subject formed the basis of creative thinking, which he had been promoting all the time. The passion that he possessed for teaching was carried through his life. He continued to teach many subjects in mechanical engineering and will be remembered by many as a likable teacher. In the mid-70s, he was appointed the head and professor of mechanical engineering at Peradeniya. Subsequently, he became the dean engineering and of course took up the vice chancellor post of the University of Peradeniya in the early 1990s in the midst of death threats. Later he was appointed the chairman of the Presidential Commission on Youth, which made radical recommendations, if implemented, which I believe would have changed the history of this country. He functioned as the chairman of the National Education Commission and was in the council of the NIE Maraka. As the chair, and he functioned as the chairman of the NIBM, and he was the first dean of the Faculty of Engineering, University of Runa. And of course, he was the chancellor of the Vayamba University. Professor Jayatilaka's services was in a variety of capacities outside the education realm. He has contributed to many industrial developments in the country. I will mention two of them, that is the Paddy Marketing Board and the Putlam Cement Factory, where his contributions were helpful in boosting the cement production by 50%. He had time for his students. He gave them sound advice and helped them with their personal problems. He was a courageous and trusted negotiator, especially when dealing with students. In these situations, he believed in eye contact. I can describe him as a kind-hearted, soft-spoken, charismatic leader. He had an invisible quality to attract, charm, and influence people. He was a mark of integrity and humility. Professor Lakshman Jayatilaka belonged to a fast diminishing group of professionals of high ethics, decorum, and morality. His brilliant academic career and illustrious positions that he held were not attained only through his scholarship, but also through his religious fortitude. Many of our friends mourn the demise of humble academic giant, a great son of Sri Lanka. We convey our deepest condolences to Professor Jayatilaka's family and friends. Over to you, Samita.
Thank you very much, sir. So next, today we will be mainly talk about innovations. When you talk about innovation, the main purpose of innovation is to improve the people's life. And when it comes to the managing businesses, like what we have at Vega Innovation, it is the key for making a kind of progress. So although our innovation activities in general may be necessarily not powerful enough to save the world, but we can focus on improving the things that we can affect. So the maybe small improvement eventually may lead to a bigger ideas, and that may one day become a revolution. So that maybe with that intention, maybe they have founded this particular company in 2013, and today You can see very young team of engineers are working with them with the theme of infinite imagination. And when you heard about this particular company, I always, as a car enthusiast, I always remember this red shiny car with many different gadgets, and that can go 0 to 100 maybe in several seconds. So that and also now that is you may heard the rumor about the electrical 3-wheel that is going to come maybe at the end of this year. They will. I heard that they are going to have like 6 to 7 production models. And also, you may not have heard about their AI Grow company, but it's a very state-of-art company that provides solution to agricultural industry. And maybe if I put it in summary, nowadays, if you look at the news and what he's talking in the society, the most two debated topic in the society is about, the food scarcity and the price hike, maybe due to the ban on imports on agrochemicals that we had a recent talk, and also about the maybe limited supply of petroleums due to the the limitation of the foreign currency reserves that we have. I think they have looks like they can address both problems in Sri Lanka with the flying colors, because they are touching both sides. So we have electric cars and AI Grow company. So it seems that is the best time to have this particular talk. So to introduce today's speaker, I would like to invite one of another key person who is always working on these innovations. That is none other than the Professor Lilantha Samaranayaka, the Director of Engineering Technology Incubation Center of University of Peradeniya, Faculty of Engineering. Dear Professor, it's over to you.
Thank you, Samita. It is indeed a great pleasure in this afternoon to introduce the masterminded brain behind Sri Lanka's first ever electric supercar, Vega, the much determined personality who has been instrumental in making the due use of the talents of the young budding engineers in the country. He is none other than Dr. Beshan Kulapala, who is connected online with us today. Dr. Beshan Kulapala is the director and co-founder of Vega Innovations, Sri Lanka. Since 2013, Dr. Kulapala has been leading a team of young multidisciplinary engineers developing high-performance electric supercars and new automobile technologies in the electric vehicle market. In addition, he is also the director of ChargeNet, which is into EV charging technologies, and the AI Grow, which is pushing the technological boundaries of modern agriculture. He is also a research scientist with CodeGen International since 2013, the parent company of Vega, ChargeNet, and AI Grow. Turning into his educational background, Dr. Kulapala obtained his bachelor's degree in electrical engineering from the University of Kentucky, a master's, a PhD in electrical engineering, and an MBA from Arizona State University, USA. With over 15 years of experience in the industry, previously Dr. Kulapala was an engineering manager at Intel Corporation, United States, during which he led a team of engineers to develop integrated debug and survivability capabilities for all CPU products across Intel. He was also the co-founder of the Validation Core Unit, Center of Expertise at Intel Corporation. With a great wealth of qualifications, knowledge, experience, and credentials, I cordially invite Dr. Beshan Kulapala to enlighten the audience this evening. Thank you.
Thank you, Lilantha, for that wonderful introduction. I know Lilantha for a long time. We worked briefly on a few things about 5-6 years ago. So it means a lot. Thank you very much. my deepest sympathies on your loss. I would like to dedicate this talk to Professor Jayatilaka and all of the other COVID patients who are struggling for their lives right now. I have one of them at an ICU, one of my teammates. So I wish him well, and all the other people who have got infected as well. It's a challenging time for everybody. So let's hope that we come out of this quickly and as quickly as we can. So today I want to talk about what we do at Vega and really to have a discussion about product designing, innovation, and what it means to have a manufacturing based policies in Sri Lanka that will help all of the other innovators to bring their products to life. I must say also that we have students from University of Peradeniya as part of my team, or graduates from University of Peradeniya as part of my team, and excellent for all of these products that that we have brought to life. So without getting into further details, let's talk about what Vega is. So Vega was Vega started in late 2013, early 2014 to develop a electric supercar in Sri Lanka. We are part of a company called Cogen International. It's one of the largest software companies in Sri Lanka, based in Sri Lanka. And we have been developing all sorts of technologies, starting from the electric supercar. So Vega means Sinhaleng Vegen Yanawage. So we wanted to showcase Sri Lankan technology, what we can do as engineers in Sri Lanka, and showcase that our students, our graduates don't have to go to other countries to do amazing things. So this is what was the primary motivation of what we wanted to do. We didn't have really a business plan or a supercar production plan when we started. So we wanted to really inspire others, and I think before COVID, there were so many students who have stopped by at our workshop to see what we have done. From all corners of Sri Lanka, people have traveled in buses to come and see what we do in this little shop that we have in Maradana. So it has been a very humbling experience to be part of this. So what we have done so far with the electric supercar is to develop a vehicle that has 0 to 100, that has done 0 to 100 in 3.1 seconds. It has about 800 horsepower and somewhere close to 760 Newton meters of torque, and a range of about 300 kilometers with the battery pack that we have right now. So if you look at these specs, it is a pretty innovation in Sri Lanka, given that this country has never built an electric car or electric supercar from ground up. So for us, I think, when we hit the 3.1 second goal, it was a big accomplishment because this was all done with local engineers using, local resources and without any industry expertise from the automotive industry, because none of them really had worked before. Most of the graduates from the local universities had just graduated when we hired them. So this was a big deal for us to get this far. So a little, a photo of our team here. This picture is a little old, so some of the members, there are some new members that are added. So again, this team comes from all corners of Sri Lanka. So this is something to be very proud of. from University of Peradeniya, Moratuwa to other universities like Ruhuna and campuses in Trinco and Betiklo, you name it. So so it's a truly a Sri Lankan product, and we are very proud of this. This is I think for me, this is the most accomplishment of getting all these youngsters together and to develop a supercar or anything with these kind of youngsters is a very proud moment for me. We started, we didn't really have a place. Trace Expert City was just getting built. Our office was in Colombo, and we didn't have really space to do any kind of workshop kind of thing. So we started small at my mother's garage here in Dehiwala to kind of to test it out, to see what what we could do, what kind of chassis we can build, and to really get the ball rolling. So to anyone who is looking at doing innovative work, I want to show this picture and tell you that you don't need to have fancy facilities or expensive buildings and things like that to start something. If you have an idea and you want to just take it off the ground, then most probably you have what you need. Maybe there are small gaps, but those can be filled. But waiting for some big event to happen to start something, I think is going to just delay on what you can do as a person. So when we started, we were looking at doing a retrofit. We were not going to build a complete vehicle. We wanted to get like a Mazda kind of a vehicle and then convert it into electric. So when we looked at that option in 2014, what we saw was that a lot of other car companies or other people have done that around the world, and we didn't really see a value in doing it. And also putting a electric drivetrain into an existing car, you're not really pushing the boundaries of technology. So what we ended up was looking at doing the entire design as well. So another thing that really got complicated is that we wanted to build all of the electronics ourselves, so including the motor controllers, the battery management system, the cooling systems, and all of that. So so from the electronic side also, this was a very complicated project because all of those things had to be locally developed. So I'm going to quickly go through some of these slides. So we did a lot of surface modeling. Once the drawings were done, drawings were done also from by a guy called Dash who lived in Sri Lanka. So once that was done, we took it into a CAD modeling system where we did a lot of surface modeling, and then we did a lot of CAD drawings as to how the chassis, the people, the components will all fit into, so that we can do simulations and whatnot to create a very industrial level supercar. So this is another picture of what some of the simulations that we did. This is for the chassis and the aerodynamics simulations to see how the chassis would behave when it would hit a concrete wall, or when it's traveling at 100 kilometers per hour, and how the wind would move around it. So all of those are very important to develop a fast car, to ensure that you get the correct drag coefficients to have the car handle properly on a highway and whatnot. So once the simulations were done, then we moved on to fabrications. This is the space frame chassis that you see. This is built with mild steel, a seamless mild steel. This picture was taken somewhere in 2014, 2015 timeframe, when the chassis was just getting welded in. So on the body part, the body is made out of carbon fiber. So to build carbon fiber body panels, just like you do fiberglass manufacturing, you need to have a one-to-one replica of what you're going to build. So the model of the car was built out of MDF and then filled with different types of foam and glues to get the shape of the vehicle. So after a few years of work, we were able to get the final finishing done to a level that that was satisfactory for us. Then we got help from the University of Moratuwa 3D laser scan to laser scan the model to ensure that it matches the CAD modeling. So there was small minor changes that had to be fixed. And then we were able to start the carbon fiber manufacturing process. So if you look at the timeline of how we progressed, we started in 2014. You can see here a more detailed picture of the MDF panels. By end of 2014, we had a chassis that was that had all of the suspension components that could be rolled. Then by 2015, the body was getting closer and closer to perfection. You can see the reflections on this picture where we wanted to ensure that the surfaces are nice and smooth because that would really affect how the final carbon fiber pieces will come out. And then from 2016 onwards, you can see some of the electronics getting installed on the vehicle and the body panels coming on, and the car beginning to take shape. And by 2017 timeframe, we started driving this vehicle. So this is when we did the 0 to 100 in 3.1 second goal, and also a lot of other fine-tuning work that we then 2018 was mostly spent on finishing, because the carbon fiber work and then the interior leather work all took a lot of time to to bring it up to quality. So a lot of time was spent on just the finishing of the components. 2019 we started the first paint work on the vehicle, and then getting all of the other little pieces like the logos and the headlights, the tail lights and things like that were done in 2019, so that we were able to take the vehicle in 2020. So last year in February, we took the vehicle to Geneva for the International Motor Show. So that is the kind of the time frame as to how we progressed in the last 6-7 years. Unfortunately, when we took the car to Geneva because of COVID, the exhibition got cancelled. So we were able to only able to showcase the vehicle on an online platform. Of course, that is nothing as to the kind of exposure that we would have got if the event was there. We were really hoping for international exposure, to get investors on board, and to take this car forward at a much higher pace. So just like that, COVID came at the most critical time to kind of put a stop on all of that. So we have been replanning to see what we can do. We have not finished the development work. We are doing component upgrades. We are putting a new battery pack to keep the vehicle in par with what the industry is doing. So I'll talk a little bit more about what we where we are with the current development work in a later slide. So in 2019, late 2019, we took this picture. So this is where the vehicle was mostly finished. Still, a few other work was getting done. This picture is from our Maradana workshop. You can see the reflections of the lights on the body panels and see how smooth it is. I think we are very satisfied with how well it came out, given the amount of manual work that we had been putting on this for the last number of years. So another close-up picture. So this is what the interior looks like. All of the leather work was done here. including this touch panel in the middle and the instrument cluster, the digital instrument cluster. Those are all digital. The software and all of the electronics was done by our team as well. This is how the rear of the vehicle looks like. And this is the picture that we took in Geneva. So this was one of the, I think, the biggest accomplishments for us to take this vehicle to an international car show and showcase what Sri Lankan technology and innovators and the young generation can do in terms of moving our country forward. I'll show you a video of the carbon fiber. For those who are not familiar with the customer wants light up, and then the headlights as well. So then on the 0 to 100 test runs, we did a few of those. I'll show you the first one where we did and then this is the 0 to 100 test, and maybe about a year later that we did to much. I'm just gonna skip to this.
Welcome to the
And I'm
unveiling
gonna
of the
jump to
Vega.
this video. So then we took the vehicle out to Colombo near World Face. Video. But, next is to look at all the components work. So that is the journey of the Vega car from 2013 all the way up to Geneva, and then once the show got cancelled, we shipped the car back to Colombo. It came back around April of last year. And then we started working on a new battery system on it and a new motor control on it. So let's quickly look at some of the components that got built because of this. You can see the history of how the motor controller, kind of moved from in time. So this here is the kind of the first version that we had to do all of the testing on the bench. So you can see components still out of the chassis, and then all of the wiring all over the place. Then the early motor controller that was fitted into the vehicle to start testing looked a little bit like this. Then we completed a lot of CAD drawings and simulation works to get it into a much better state. And then we this white chassis one here is the one that we drove to do the 0 to 100 in 3.1. Of course, the newest one looks more like this one. It has an aluminum fully CNC chassis. This motor controller can handle about 350 kilowatt of peak power. It operates up to 900 volts and 600 amps, liquid cooled, and has a variety of technologies, solid state devices to kind of give the power at the right density and with the right cooling systems on board. So some of the other components that we have built for the Vega car, the battery pack. The first one was a LFP lithium ferrous phosphate 40 kilowatt hour battery that had a range of about 240 kilometers. This is also all three are liquid cooled battery systems. Then the current system that is on board is a NMC type battery system, 55 kilowatt hour. It has a range of about 300 kilometers. And we are working on a NCA-based system that has much higher densities. We can pack about 130 kilowatt hour into the car, and that would have about 750 kilometer range. So this is the kind of the last one is what we are working on right now. It's in a R&D state and will be fitted into the car in the next coming months or years. So again, the motor controller that we looked at. So the instrument cluster that we talked about. So this is a complete digital system with C-based programming done. These digital infotainment and instrument clusters alone, this business alone is a multi-million-dollar industry in the world. So we want to see what we could do in terms of getting development work for this kind of industries, because we have so many software engineers in Sri Lanka, and the margins are much higher in these kind of sectors. Vehicle control unit is also done by the team. Then there is thermal management, the charge controller, and then multiple other units like the body controller, the door control systems, the light control and climate control. So these are all components that we built within the team to fit into the Vega car. Now, if you look at a Tesla or the Rimac or some other electric vehicle car companies, most of these kind of components are from other vendors like Bosch and Continental and things like that. So what we chose to do was to develop all of these components ourselves to see what industries we can kind of hit into. That decision has pros and cons. We can talk about in the QA time frame. So with this kind of experience and technology, we were able to do a whole bunch of other things. So the first one we did was to convert a petrol mini car into electric. We put the same technology that went into the Vega car into a small car like this. This is the one and only properly converted and registered electric car with the Department of Motor Vehicles. So we went through a whole bunch of inspections, reports, and rounds of discussions to get them to trust that this conversion was done properly to be registered as a electric converted car. So what we are hoping is that like in the other countries, we could kind of open up a market for electric conversions. Although this is a very difficult market to currently work on because the vehicles are expensive already, and then the conversion is again more expensive. So we have not been able to really penetrate the market and find people who are willing to invest that much of money. So battery costs are going down over time. So we are hoping that in the future that there will be a market for this. The next and the latest one is this electric three-wheeler called ETX platform that we developed. Electric three-wheelers is it's a global industry, and we want to be part of that. Of course, three-wheelers in Sri Lanka has a very negative impression because mostly about how it's been driven, all of the accidents and whatnot. But three-wheelers are something we all use, so it's a very sensitive subject that I would be willing to talk about as to why we need three-wheelers. I'll show you a quick video of a trailer that we released in the last few weeks. This platform is a complete new electric three-wheel platform. One of the biggest primary problems with the Indian three-wheelers is the safety aspect of it. Now, three-wheelers inherently has a safety limitation because it has three wheels, the passengers are in the back. the driver is in the middle. So inherently it has limitations. But if you look at the Indian three-wheeler, the upper part of the system doesn't have any kind of reinforcement. And also even the bottom section doesn't have much at all. When it hits with an accident, it bends into two. And severely injures the driver. So we wanted to take a look at that problem and to come up with a new solution that can really have a safe platform on board. So this has multiple levels of crash bars and impact absorbing materials to really be able to control how it would behave in an impact. Also, what is new here is the amount of cargo space that is available in the three-wheeler. The petrol three-wheelers, the rear section can hardly be used because there's an engine in the back. Of course, in an electric three-wheeler, the battery pack and the motor controller can be fitted on the bottom, so that a lot of space can be enabled for cargo as well as for passengers. The inside we have, really made it more leaner. It's very digital. It has a lot of features, digital features that can enable multiple levels of safety. So, for example, if the handle is turned a lot, then your acceleration can be limited, so that when you are stuck in a traffic somewhere, the three-wheeler guys can't really turn really quickly and then accelerate and go, because digitally we can control that. And also, if cities like Colombo or Kandy wants to have limitations on the speed, we can have virtual fencing, kind of a digital system on board that can limit the amount of high speeds that they can do in certain areas. So things like that can be enabled on an electric three-wheeler to really control how it's been driven, so that you can mitigate some of the negativity that is associated with electric three-wheelers or three-wheelers in general. In addition, optional solar panel can be fitted on top of the vehicle that will give a 10% boost in terms of range. Three-wheelers are, when it's driven or if it's sitting in one place, mostly it's under the sun. So this is a good option to kind of use renewable energy to get it going. And of course, the cargo space, like we talked about. So in this space, you can actually put a washing machine, a big TV, or a bicycle, things like that can be loaded for city use. And also, we are looking at this from a rural aspect as well. Electric motors have a lot of torque, so this can be driven on very high, steep roads to farms and hena. So you can load it up with a lot of agricultural produce that you can bring it to the market. So we are looking at that aspect as well. Now, a lot of people ask us why build electric three-wheelers. So there are many reasons why we are building an electric three-wheeler before we get into an electric small car. Electric three-wheeler is much easier to build. It has less components because it doesn't have doors. It's mechanically much more easier to build, because our country really doesn't have big molding facilities, CNC robotics and things like that. So this is a very, it's going to be a very manual kind of a manufacturing process. So we need to start with a simple model. And if you look at the global market right now, it's about a $30 billion industry for electric three-wheelers. Now, if let's say we are able to capture 10% of that, that's a $3 billion company that we could be getting into. $3 billion is a lot of money, especially when if you look at the current economic crisis. We are trying to look at trying to get $1 billion. How we are trying to see how to pay off a $1 billion debt. So $3 billion will make a huge difference to our country's progress. So, we are looking at the global market, the Africa, the South Asian and the South Pacific Asian countries. And we already have a lot of requests from Ghana, Kenya, some of the African countries looking for a vehicle like this. So I think from that aspect, there is a huge potential that we can play. If you compare ourselves with Bajaj builds about 1 million three-wheelers per year. 1 million three-wheelers per year. So that's a lot of three-wheelers. And they export most of it. So, so this would be an ideal way to kind of bring the manufacturing process into Sri Lanka and really use some of the ports in Colombo and Hambantota to start exporting these units to other parts of the world. Now, if you look at the running cost of a three-wheeler, it's about 5 rupees and 80 cents for a petrol three-wheeler for each kilometer. This is at 137 rupees per liter kind of a model. Now, if you move into electric with the current tariff rate at home, then you're looking at about 3 rupees and 60 cents savings. And if you have solar at home and you're able to fully charge the vehicle with solar, then your cost of a kilometer is 75 cents or 72 cents. So you can see the business aspect of why an electric three-wheeler makes sense. Your cost of driving it will come down, and we have roughly more than 1 million three-wheelers right now. Imagine the amount of petrol that we have to import. So if those can be moved into electric, there's a huge saving potential for the Sri Lankan government as well. And then three-wheelers are notorious for the amount of exhaust that comes out of it, especially the two-stroke three-wheelers. So if that can be limited, then urban cities like Colombo and Kandy can really benefit from electric transportation as well. Now, if you look at the 5-year running cost of a three-wheeler, what we have calculated is that if you have a petrol three-wheeler, you're looking at about 2 million rupees to buy a three-wheeler and then to operate it for 5 years. Whereas if you have a electric three-wheeler, you're looking at about 1.5 million rupees. So it's a savings of a little less than 5 lakhs. And if you have electric plus solar at home, then your cost of ownership is about 1.1 million rupees, which you're saving about 1 million in 5 years. So again, even from a cost of ownership point of view, with battery replacement added, you're looking at half the cost. So there's a huge potential for electric three-wheelers to really change how we our last mile kind of transportation needs. We are also working on so this is a small electric vehicle, mostly for farming and sport and tourism kind of sectors. So you can think of these as the replacement for the Landmaster, for example, where these have huge you can fit all sorts of different accessories into these to help with your farming needs. So these are being used in other countries for agriculture basis. So we want to see what the potentials are here. So we are looking at, it can tow or haul about 600 kilos of weight and really have be used for, all sorts of tourism kind of activities and then for the work kind of activities. So it can be used for farming, for the industrial use, as well as for estate management as well. So that's another thing that we are working on. Then apart from the automobile stuff, we have been looking at a lot of other technologies. So we have a business called ChargeNet. In the interest of time, I might go through these slides quickly. So we are the Sri Lanka's largest electric vehicle charging network. We have a dedicated team to build to design, build, and manufacture and install electric EV chargers in Sri Lanka. So our customers are mostly using these kind of electric vehicles, from the Nissan Leafs to Tesla to BMW, Range Rovers, and so on. So all of these vehicles are, driven in Colombo right now. And these are our, charger products. These are all manufactured here in Sri Lanka. We use the same expertise that we build the electric car to kind of put these together. And we are proud to say that we are exporting these EV chargers to other countries now. Right now, our chargers are in India, it's in Ghana, Kenya, and we are in the process of exporting them to UAE, Qatar, and Pakistan, as well as Bangladesh. So this is we have an international collaboration with a company called EV Cosmos in Bhopal, India. They have already installed and deployed chargers in India. And we are competing with giants like Tata and Mahindra in terms of our technology. So it's a very fascinating, very challenging area, and we are very proud of build electronics and products to a country like India, where it's a very challenging market out there. And then this is a picture of the charger that is installed in Nairobi, Kenya. And this is also a very buzzing country in terms of growth. And most of the African countries are very good places to do business right now. So we plan to increase our production runs in the next few years. We are putting up a facility in Rajagiriya to manufacture these. And in other parts of the country, world, to really accelerate and take our chargers to the international market. This is one of the new chargers that we are looking at that can be exported to the European market as well. We have a mobile app that is part of the solution, so people can use this to pay their bills, to start and stop the charger. So there is no need to handle cash. You can just drive into a charger, use your app and start the charge. And then you can get billing done. You can look at profit shares and look at the charging station owner. You can see the usage statistics of your systems and so on. So it's a very end-to-end kind of a solution. Then we are looking at CE standards and IEC standards for our next generation chargers, so we can sell them to Europe. We won a bunch of awards for the work. This is from the United Nations in 2018, I believe. This is a Swabhimani Award in 2017, and then also in 2018 and so on. So our customers, currently we install chargers for people's homes as well as businesses. So companies like MAS, John Keels, Lanka IOC, some of these big names are using our EV chargers. Then the last one is the AI growth. So it's an interesting story how we got into this. Our workshop in Maradana had a concrete roof, like a slab, and it was getting very, very hot. So we were wondering what to do with this. So then we looked at putting up a greenhouse there, and then when we started researching greenhouse operations, we saw that there's a huge potential out there, an industry out there for agriculture technology, especially for greenhouses as well as drip irrigation and things like that. And then we kind of got into this. To be honest, this is a very it's a very enriching kind of a area to work on, because food safety is key for everyone. We are all concerned about what we eat, what our children eat, the amount of fertilizer and pesticides that we put into our bodies. So if we can streamline that, if we can really add value to the farmer, then the farmers can really uplift their lives. If you look at the vegetable and fruit kind of agriculture produce, the supply chain of it, the farmer is the least paid person. They are, although they put so much work and effort into this, it's very difficult for them to come out of poverty. The middleman takes a lot of the money, and then the supermarkets and then the final retailers also make a pretty hefty amount. But the farmers are stuck in this one spot. So we want to change that. We want to see the farmers get a larger chunk of the money because they really deserve it. So this is where AI Grow is coming from, to really add value to the farmer. Now, if you look at the industry, there's a lot of talk about IoT and robotics and all sorts of quadcopters and things like in agriculture, but it's hardly used because it's difficult to sell units to the farmers, and also it's difficult for people to use. So what we are trying to do is to simplify this technology, to bring the cost down, and to really showcase value. So from that aspect, what we have created are a number of devices and a software solution that really provides end-to-end farming solution. And you don't have to have the whole solution at once also. So some farmers, they only want to monitor the amount of moisture in their field. Some want to automate the fertilizer. Some want to have the software part where they can manage their farms, and some wants to have it all. So it's depending on the need, we can provide the kind of solutions that we want. Again, all of these devices are also proudly built by us in Sri Lanka. So we have a grow box where you can do a lot of experimental work for agriculture. Then we have a fertigator that you can control the amount of fertilizer. Then we have a climate control system, a handheld device, then a home drip irrigation system, and then also a smart sensoring system. So how we are different is, let's say, for example, you own a greenhouse and you are growing tomatoes. So the moment you put the seeds down in your greenhouse, you tell our software solution that you are putting these seeds down into the greenhouse grow medium. And then the software solution will tell all of these devices that now you are growing tomato seeds in this greenhouse. So then from that point onwards, the farmer doesn't have to control the fertilizer, because the software and the electronics knows that you're growing tomatoes in this greenhouse. So it will all automate the right fertilizer recipe on a day-by-day basis to the tomato plant that is now growing. So it will first grow its leaves, then grow its flowers and fruits and so on. So the fertilizer need of that plant will differ on a daily basis. So this technology will automate that. So it's a very simple as that. It's a complete automation system that you can bring in to really bring data-driven agriculture into our agriculture system. So we are an end-to-end service provider. We provide seeds, fertilizers, we build greenhouses, we provide the technology, and then provide sales channels as well as to, what do you do with your tomatoes and lettuce. So, so we provide a software interface and a hardware interface, as well as we provide expertise as to how to grow, how to harvest, post-harvest, package, and how to sell. So it's a complete end-to-end system that we have. Some of the pictures of our products that we have. This is just a picture from the web. That's the fertigation system. This is the sensor node that we talked about. It can capture CO2 levels, humidity, temperature, EC, pH, things like this. This is the grow box. These are LED lights that we have. And then there's a mobile app solution that we provide with this as well. So you can monitor various aspects of the things. We are building an AI-based cloud server that can monitor these data and give valuable information to the farmer, or to help him with the decision making. And then we ourselves package the lettuce and we provide it to most of the supermarkets in Colombo. We do strawberries, lettuce, tomatoes, bell peppers, even mushrooms now to various players. We build rooftop greenhouses with multiple levels. And then we have won a bunch of awards on this front also. So yeah, so these are the kind of the work that we do as part of Vega. We have a few other things that are going on that are not part of this slide deck. We have plastic reduction systems that we are building vending machines for. We are piloting a system with Unilever now at multiple locations where you can take your own shampoo bottle and fill it at the grocery store, so that you can save the amount of the plastic that you will use, and you get a discount also. And then we also have a reverse vending machine where you take your old plastic bottles and you put it into a machine, and then that machine will also give you coupons or cash back so that you can use it at the supermarkets. So things like that are also part of our product portfolio. So yeah, so those are my slides. I would love to look at some of the questions and concerns that you may have, and see how I can help with those.
Thank you. Thank you very much, Dr. Beshan. It is indeed a very interesting topic, and we have all enjoyed it. Being a civil engineer and also a faculty member at Peradeniya, we mostly get the fun with the concrete, but this is indeed a very interesting topic about this IT field. So to moderate today's discussion session, so we have another very distinguished person. That is Dr. Kamalanath Samarkon, the head of Computer Engineering Department of Faculty of Engineering, University of Peradeniya. So over to you to moderate the discussion. Yes.
Thank you very much, Samita. Can you hear me?
Yes.
Yeah. Thank you very much. And Dr. Beshan, now we had a nice presentation, and I think it's really interesting and excellent and informative presentation. We actually highly appreciate the role, because I'm from the computer engineering department, and also I have been working in the industry for long. So we highly appreciate the role of Vega innovation in shaping the and then also setting an example for Sri Lankan engineers, to show the role of engineers and engineering organizations in Sri Lanka on how to start and operate innovative local industries in the hour of need, because now we are really desperate now. So the innovation is most probably the only solution for the problems facing by Sri Lanka at present. And then the role that the engineers can play in all the disciplines that you are playing, like in electrical vehicles, robotics, AI, agriculture, and mechatronics, manufacturing, hardware, software. So there is, I mean, a lot of rooms for us to play. But the issue is that we are not been doing that. So that is the problem. And then I know that, I mean, there are many issues. The support that we are getting from the authorities, and also the facilities that we have are limited. But amidst all these things, I mean, you are doing really well, and that gives and I mean, motivation for all the engineers to work in those fields. And as you said, like, there are many areas that we can work on. So to start the discussion, first I will open the discussion, because I have a couple of questions, but I will come into them later. So first we'll get the questions from the chat box, and then if there are any participants who raise their hands, I can select them also. So the floor is open for the questions. So thank you very much, Dr. Beshan, for your wonderful presentation, and let's go on the discussion. So the first question was about the three-wheeler. I think yes. Can the price of three-wheelers be affordable? As presentation, I saw that it is affordable, but over to you. I mean, you can elaborate on that.
Yeah, so it's very important for us to make our three-wheeler competitive, so it will cost less than the imported three-wheelers from India. This is where import taxes will and policies will help local innovators to take their products to market. If the current tax rates are held, I think not just held, they will have to increase it as well. Then we will certainly be competitive. We will provide a three-wheeler that is cheaper than the Bajaj that is imported in from India.
Yeah, so Engineer Tilakaratne is asking, how do you manage with the cost? I mean, can you a little bit elaborate on that, Engineer Tilakaratne? What are you referring as the cost of? How do you manage the cost?
I'm saying now Vega is now being in under experimental stage. Now there are so many staff working with the material and everything. So, so what is the how do you manage with the the cost? Still you have not anything sold out. So there are some bigger cost is involved in there. So what is the method you apply? What I don't know.
Even though we don't have the final three-wheeler in-house, all of the components are part of a BOM analysis that we are after. We are looking at vendors for things like the wheels and brake parts and things like that. So those will be imported from various countries to keep the cost low. So if the current tax percentages are held for imported vehicles, then certainly our vehicle will be cheaper than an imported vehicle.
Engineer Nimal, did you get?
Yeah. Actually, I referred not the electric vehicle. Now the Vega vehicle. Now you are working from 2014 up to now. So you have spent a lot of money on that. So that money still you have not sold out anything. So that's what I'm asking.
I see. Okay, good.
Maybe
So
the financial model, overall model, how you? I mean, we have been. Yeah, we have about 25 engineers.
So the Vega car is a
sorry, my phone died, but I think y'all can still hear me, no?
Yeah. Yes, we can hear you.
Can y'all still hear me?
Yes. Yes, Dr. Beshan, we can hear you.
You can hear me, no?
Yeah.
Yes. Okay, good. So the Vega car, yes, it's a big investment, and it has been a big investment for the last 6 years or so now. And we are fortunate that a company like CodeGen is continuing to invest on it. But you have to look at it from a potential point of view. If you look at Tesla or even the Rimac, the electric car company in Croatia, recently they were invested by Porsche and some of the other big companies for more than $400 million, and they are putting up a factory that can house 2,000 engineers to develop vehicle platforms for the big companies. So we are also looking at investors like that. So it's not a short period run that we are looking to kind of sell the car and make money. But it's a long journey ahead, and certainly investors will play a major role. But also all of the other technologies like the electric vehicle charging network, even the agriculture technology are part of the technology that was built for the Vega car. So the IoTs, the power electronics, the protocols and things like that are all part of the technology that was built for the vehicle. So now we have been using it for other aspects and commercializing it. So so it's not like we didn't sell an electric Vega supercar and we are not making money, but we are making money from various other aspects of the technology.
Sure. Thank you very much.
Yeah, there are. I mean, there's another question asked by Engineer Sarath Seniratna. Are there any traditional farmers who have used these technologies?
Yes, so we are working with a few traditional farmers who are, controlling their pumps or their gates for watering and things like that. Those are very low cost kind of solutions that we have with the traditional farmers. But we also work with greenhouse owners and plantation owners for some of our advanced technologies. So really depending on the need and depending on how much they can afford, we kind of formulate what we provide for them.
Okay.
Thank you.
Yeah, thank you. And then there's another question from Engineer Vandula Tilakasena. How is Vega looking at electrifying bus transport?
We did a number of studies and to see how we can use electric buses for the how to convert buses into electric. But we have not been able to find a good cost-effective solution, to be honest.
Okay, thank you. And Professor Lelanta is asking Dr. Kulapala, you started converting EVs with Mini, and as you mentioned, the initial price of Minis is higher, and therefore the cost would not be affordable. However, we do have about 1.5 million three-wheelers on the road. What is the bottleneck to convert the existing IC engine-driven three-wheelers to electric three-wheelers? Did you get the question? Dr. Beshan, are you there?
Hi, sorry, I think I got disconnected.
Yeah, did you get the question? It's about asking whether, how about converting three-wheelers, existing three-wheelers to electric three-wheelers?
Yeah, we've been trying to get international grants to help with this. One of the problems that we see is electric three-wheel owners. Three-wheel owners don't have the money to pay for a conversion. So that money has to come from elsewhere. So we are looking at international grants from the UN and other places to help with that. But if those grants are available, then certainly we can build a package that people can use to do the conversions.
Okay, thank you. And Engineer Sisira Jayama is asking, I am proud of all your innovative products. I can see many developments in renewable energy solutions, but why none has given attention on biodiesel as a transportation fuel? I remember Dr. Sarat Senaratne has done many research on this, but nothing much progress after that.
Yeah, I'm not very familiar with biodiesel, so I'm not, I don't think I can comment on it. But you're right, there's all sorts of other technologies that we should be looking at as a country, especially, these hydrogen as well. And I think if we can find people to work on those, that would be fascinating. Yeah.
Can I add something on that?
Yes, sir.
Yeah. Regarding biodiesel, yes, as you mentioned, we did a lot of work on biodiesel long years ago. The problem is not in the technology, but in the agriculture. So there's no raw material available, or there's not enough raw material available for that. That is the problem.
I see.
Dr. Sarat, I'm wondering, because we are an agricultural country, if we want that, we must have, because in Portugal they have a biodiesel plant. They import rapeseed, and they produce 5,000 tons per hour biodiesel. They are importing from America. So in our country, we are an agricultural country, but we are not thinking of any such seeds that we can grow here, I think.
Yeah, thank you very much. And there's another question from Francis Emmanuel. Thanks, Beshan, for inspiring presentation. In the agri-tech sector, has Vega any real-life examples in Sri Lanka? Particularly interested in knowing how system integration solution work.
Yeah, we have greenhouses in Kegol, Gaul, in Colombo, Batiklo, in Homagama. So about 15 clients that we have partnered with. They use the entire solution or parts of the solution. So yeah, we would be very happy to discuss more details offline as to what our solutions do and how it is been applied. But it's been used, especially on the greenhouses sector.
Okay, thank you. And Engineer Gamunu is asking about electric three-wheelers converting. So, Engineer Gamunu, do you need, because it was answered that question?
Yes, I got the answer right.
Okay. And Engineer Karu Leather is asking, are these charging stations differ for different brands and models? If so, is it possible to make a standard type of charger?
Yeah, unfortunately, in the current world context, there are about 3 or 4 charging standards. So they come with different kind of charging plugs. So this adds to the complications. There are some movements now to kind of worldwide standards to come together and build something. But our chargers have all of these different kind of protocols like CHAdeMO, CCS2, level 1, level 2, kind of different charging systems.
Okay, thank you. And Dr. Devasurendra is asking, how do you manage in terms of market penetration with respect to competition for the $1 billion EV market in overseas markets?
Yeah, it's not an easy task because they won't give us the market share just like that. But if you look at Bajaj, they have not been able to get into electric vehicles yet because they're still, they are big companies. Big companies notoriously have problems of being flexible and getting into new technologies quickly. So this is where we can really, as a small startup kind of a company, we can have that benefit of being nimble and flexible and get into these spaces faster than them.
Hello, can I ask a question there?
Yeah, Dr.
Related to that? Dr. Beshan, the problem is this now, you develop things, right? People can steal, right? In the sense, you get up to a point and then the big players can come and basically hijack a project, right? Since in places like Africa, the intense competition from China, from Europe to get in there, and you say $10 billion, 10 billion, right? So then you can start up something and it can hijacked by BS. Now, how do you generate? You need inertia, kind of momentum that you have to create, to go forward. So for how can we doing that until these people come and get it from you? That is my first question, right? Because that's I think is a big threat for small players like us. Can you get it? Can you hear me?
Was it clear?
Yes, I think I understood the question. So, really, at the end of the day, your product and your solution that you're providing must be better than what is available in the market. If that is not the case, then it's very difficult to compete. And if you have that kind of a solution, then yes, you can get into a market and kind of start growing. And if you are growing too slow, then what the problem that the question that you're raising will come up, where others will catch up with you much faster, and then you won't have a space to kind of live. So this is where you need to scale quickly. You need to find international or local investors, and then get the government on board to have the right policies to accelerate quickly. Because if you build the best three-wheeler in the world and you take it too slow for the next 1.5 years, surely there will be another company who will come and do it much faster and take all your businesses away.
If you permit, can I ask a related small question? Yeah. Dr. Beshan, now the thing is now, see, now we are not talking about rocket technology. No, the thing is the technology existing and people can master it. Now the thing is, it is about, now for instance, it's about material. It's about quality. It's about the electronics that you create, right? How long it will last. Plastics. It's about the polymers that you use, right? It's about how the things will corrode. See the life cycle costing, if you like, right? So those lines, right? So the bigger players they have already invested in technology. Now you have to. Now I'm telling you, I'm just telling. Develop line.
Dr. Devapriya,
For instance, when you have the car, you have mild steel framework, right? Now, is it galvanized? Do you hold deep galvanizing of mild steel framework? Because it fights, right? I mean, in kind of a environment, right? Right. I mean, because there is a whole host of other developments that go with it, you know, to make the product right. I'm sorry. I mean, I had to say, I'm a chartered mechanical. These things concern me. Right? Sorry. Thanks. Yeah.
Yeah.
No, excellent points. I think over and over again in the world, if you look at other companies, other small companies like RIMAC, RIMAC in Croatia, it's a very good example because they are also a tourism-based country. It was started by 25 people about 10 years ago. Now there are about 300 people. They have invested about $500 million from other companies. So these startups, they can do a major difference and a disruption into the market. And over again, in the other parts of the world, this has happened. So I think just being a small company in Sri Lanka is not an excuse anymore to say that it's very difficult to get into these markets.
Thank you.
Okay, thank you. And the other question from Engineer Sisira Samarasekara, the leaf became unsuccessful due to problems of replacement of batteries. Any solution to this?
Yeah, the leaf owners had a very unfortunate history in this country. You know, buying the Nissan Leafs in 2014 kind of time frame. The early Nissan Leafs, you know, their battery systems weren't built to last this long. And then Nissan itself is not providing a replacement battery. So the Leaf owners are not very happy at all. And it has put a very, you know, a big black mark on the EV industry. And that's very sad to say. We have looked at Nissan Leaf battery pack replacement opportunities. And for us to build one, it costs about 1.2 million rupees. Whereas the EV owners are only willing to pay about about 4 or 5 lakhs. So we don't have a cost-effective solution for the Nissan Leaf.
Okay, thank you. And then Prasililanta is asking, so delighted to see the electric three-wheeler design. I believe the battery chemistry in the Vegas electric three-wheeler is lithium-ion. If so, how would you handle safety issues?
Yeah, so safety is a big concern, especially from impact on a electric vehicle. Also for any kind of other electrical shortages. So we have a very advanced battery management system on board and a power delivery unit that monitors various aspects of the battery pack. So thermal runways are looked at, different kind of materials we are putting between the cells and the battery pack system, so that if there is a fire, then the fire won't propagate into the other cells. And we have done destructive testing as well to ensure that if there is a short, then the proper fusing blows off. And if the cells do catch fire, then to see what happens to our battery systems.
Yeah, Dr. Beshan, now related to that same question, I'm just asking whether the quality assurance certification process is there for this kind of developments.
Yeah, we want to look at what are the industrial standards for the QA side of things. And unfortunately, in Sri Lanka, there is no body for these kind of certifications. So we are working with the Indian partner to take our products there for the final certification. And I think that will be a very important step to build the confidence for exports.
Then Dr. Kamal Aksar is asking, what are the barriers we have in starting Vega cars manufactured in here in Sri Lanka in commercial scale?
Oh gosh, the barriers. I mean, we don't have policies to have manufacturing in this country, to be honest. I'll give you a good example. If you take our EV charger, the components that we had to bring in, like the transistors and things like that, they're all taxed at 35% or even more sometimes. But if you bring an electric vehicle charger itself from China, you can bring it just for the NBT of 5%. So really, there is no people who are manufacturing is not rewarded in this country, and the policies aren't there. And I don't think we have spoken to every government on this, and nothing has moved. I don't think they understand this as well. So if it's an imported item, they are very happy. But if it's a manufactured item, they don't seem to understand the need for it. So I think we all have to get together and do a lot more work on that front.
So there should be a cultural change that is
yes, a cultural change. That's right.
Then there's another question. What is the minimum cost of a home hydroponic system?
Our home drip systems, they start from about 20,000 rupees, I think, if you want to have a home drip system. It really depends. If you just want to have a rack and you want to do hydroponics, then I think even for 10,000 rupees or so, we have a solution that we give. So depending on what you want, really.
So you have a hydroponic as well as a drip irrigation both, right?
Yes, that's right.
Okay. Thank you. And then I think this
Dr. Vijita Herath raised his hand.
Yeah, I will come to Dr. Vijita. I mean, shall I move to Dr. Vijita? Yeah? Dr. Vijita?
Okay. Can you hear me?
Yeah, sure. Yeah.
Yeah. I have like few small questions with regard to three-wheelers. Normally they are rugged use vehicles, and then there's the issue of serviceability at the place of use. Have you thought about those things in your design? And the second thing is with regard to the car and the three-wheeler, have you completed the legal framework to put them into the road?
All good questions. Yes, so we have been looking at serviceability. What happens if you drive the three-wheeler in a flood kind of an environment? What tools will be needed at the service locations, and what training will they need to do? So getting these electric three-wheelers into the market is it's a very disruptive, it's a massive undertaking, because there has to be a cultural change once again to get this going. So those have been looked at, but there's still a lot of work that we need to do. So that work is still ongoing, and we are trying to work with partners like people who have already expertise in the industry for three-wheel servicing and repairs to kind of help us to partner up and take it forward. On the vehicle side, the Vega car is also is officially registered with the DMV. It has a chassis number and the plates and everything. That is a registered car, as well as the Mini Cooper. Three-wheeler, we have not taken it through the system yet. We are waiting for the a completed prototype to get done, and then we will submit it to the DMV for prototype testing, validation, and then get the type certification so we can manufacture and sell it here.
Okay, thank you. And Dr. Deva, please
thank
asking.
You. Sure.
Yeah, Dr. Devasurendra is asking the impact on power sector install capacity when more vehicles go electric, and also impact on traffic. This is a broader question, but.
Yeah, I mean, the whole world is moving into electric, and I think whether we like it or not, whether we are ready or not, the vehicles that will be built by the Hondas and Toyotas will be all electric pretty soon. So, I don't think there's a choice but to move forward. On the renewable energy side, we are working on a low-cost solar inverter as well as a home battery power storage system. so that you can use solar power, store it in a battery pack at your home, and then use it for your home use or for your EV transportation. So we are trying to tackle that side also, to use renewable energies for this sector.
Yeah, when we
can I please add to that?
Doctor,
Please. So the problem is, Dr. Beshan, this is really great. But the thing is, now the moment all these vehicles go electric, the install capacity, the power, right, might affect the traffic. I mean the you see the way that it is be with the electricity board, right? Okay, so these long-term things, can they manage? I mean, if more and more people, even the CB might now, we have to, and they might even say we don't have enough install capacity. Right? So there's another story there, like that. Right?
Yeah, I think
it is a necessity.
Sorry, you're breaking up.
Yeah, Dr. Beshan, yeah.
What I was going to say is, this is where, countrywide policies will have to be in place. CEB and the transport, all of those policies have to align. Otherwise, we are going to get screwed up as a country in the next 5-10 years.
Yeah, and also when you take the complete energy cycle, I think the efficiency wise, it should be much better, right? So it should be. And
yeah, I understand. I mean, you have to work on policy, right?
Policies,
I mean, you have to work with the government. Yes, right? I mean,
and
the institutions and so on. I mean, right? So
yeah,
to get the policies changed. Right? Thanks.
Thank you. And Engineer Sarath Srinivasan asking Dr. Nalin Karuna Singh developed a three-wheeler conversion project. There was a long waiting list, but the project was abandoned. So it's not a question, but a comment.
Yeah.
Well, do you have anything, right?
It's a statement only. I think it's not a question.
And Engineer Niroshan Dharmaratna is asking, proud on development of technology in Sri Lanka. Trust more than manufacturing, this technology development might help Sri Lanka. Whether Vega is ready to sell or partner with bigger investors and have a future of such development in Sri Lanka.
Sorry, what was the question?
Yeah, it's a comment also.
Okay.
Yeah, whether the Vega is ready to sell or partner with bigger investors.
For the Vega supercar, yes, we are ready for investors, and we have been talking to a lot of potentials as well. But to be very honest and frank, we haven't closed on any investor right now. But we are really hoping that we can in the future. We are looking for somebody who already has, like a big car company like Toyota, Hyundai, or Porsche or Jaguar, somebody like that to come in, where we can do R&D work from Sri Lanka for them. Imagine if we can do research and development, then we can assign all of these mechanical, electrical, electronics engineers from our universities to develop amazing things for them for their work. So that's what we want to do.
Yeah. And then you answered the second part also, and have a future of such developers in Sri Lanka. So that is what you are thinking, right?
That is absolutely correct. Yes, because those are very high value items. Unlike software, where they can go to Bangladesh or Philippines and do it for cheaper. If we can build a automotive ecosystem here, then that has a lot more potential to get real revenue into the country.
And the next question is, I think it's not only to Dr. Beshan, I think public question. Request. We have developed a low-cost oxygen concentrator, but have difficulty in sourcing COLI. Can anyone help? So it's a question to all the participants, I think. Engineer Sister Samarasekar is asking the question: if anyone has some solution, we can you can contact PEFAA and we can convey the message, or you can contact Engineer Sister Samarasekara if you can put your email number directly. Engineer Sister Samarasekara, can you, is it okay? Maybe he's...
Yeah, I will do that. Sorry.
Yeah, please. So,
Yeah.
anyone who can
I will
help him,
put yes, I will put the email for everybody. Actually, we are importing oxygen. Yes, I will put the email for everybody. Actually, we are importing oxygen. Sorry, there's feedback.
Yeah, that's right.
I will put the email for everybody.
Yeah,
we are importing oxygen at very high cost from India and Singapore. When oxygen is available in the air, which can be just taken off with the concentrator.
Okay, so please put your email, and if anyone can help, you can contact Engineer Sister. And then
so just to add that, I put it in the comments also. There's a company called Mitsui in Sri Lanka. They can source different materials. I don't know if they do zeolite, but you can talk to them. I put it in the comments also. Mitsui.
Okay. Yeah. Okay. Thank you.
Thank you very much.
You're welcome.
And then Engineer Karu level is asking, what steps are there to protect your finding without being copied by others?
Yeah, that's a risk that we have to take, and I think when I talk to a lot of Sri Lankan innovators, they are very worried about their designs being copied, so they don't want to share it, they don't want to show it. I think the world has moved beyond that. If you're too worried about what you have and you're keeping it too close, then it's not going to get into the market very quickly. So I think we need to have a mindset change where we are very open. We want to work with others to quickly take things to the market.
Yeah, and having the design alone won't help. Like, we need the process also. So that's
right. Yes. So a lot of people have to get together to take it forward.
Okay, thank you. And then Engineer Bandula Tilakasan is asking, what would be the charging time for the three-wheeler ETX without solar backup?
So if you are slow charging the three-wheeler, it's about 2.5 hours to completely charge. If you are doing a fast charge, then you can charge in about 25-30 minutes.
Okay, thank you. And Engineer Adisha is asking, unit cost of a local level 3 charger is much higher in Sri Lanka, so that people do not get much benefit by using EV when they have to charge the car outside. Any solution for it?
I mean, yes or no? Running an electric vehicle is cheaper in Sri Lanka when you compare the fuel prices and all of the service that you have to do. Renewable energy is one way to kind of lower the cost. PUCSL has a electric vehicle tariff rate of 12 rupees for EV charging, but the unfortunate issue is that they will only provide that for an individual meter just assigned for a EV charging unit, and there is really no practical way to have a meter just for the EV charger, because CEB gives only one charger per premises. So that there is a problem in the policy once again that we need to fix.
And also, as I know, the scheme is not attractive because daytime charging is high, I think. The tariff is higher.
That is also correct. Yes.
Yeah. Yeah. The other question, Engineer Himaya is asking, will the increase of scale of production reduce the price in this case? How do you think about the portion of renewable energy in national grid and efficiency of reducing carbon footprint?
Most definitely, volume will affect the pricing. This is a given for many things in manufacturing, maybe all things in manufacturing. So the more we can build, the less cost it will be. In terms of using natural renewable energies, then yes, you need to have a storage system because you want to store the solar light energy that is generated mostly during the daytime, where the dips are, and then use it during your night time. So that is one thing. And on the last question, I think your emissions will come down definitely if more electric vehicles are out there.
Okay, thank you. And then Engineer Sister is asking, it's a comment like, when you develop three-wheeler with looking all other aspects like reducing running costs and safety, etc., are good. But if you want to use it in our roads, we must first have good drivers or separate lanes for three-wheelers. Otherwise, better make it for export. I know that, I mean, you are aware about this.
Yes,
about
I mean,
three-wheelers.
how the three-wheelers are being used has been a big problem in this country. But if you look at the worldwide market, countries are moving into three-wheel segments, even some of the European countries. I think so.
They have
it's a difficult thing to solve.
Yeah, they have things, but we don't have. That's the problem. But there's maybe a joke, but there's one solution that if you have a buffer similar lane similar to other vehicles in the three-wheeler, then they cannot run like that.
That's right. Yes.
So one of the questions I had was like, now why three-wheelers are I mean, because of the shape, now they tend to enter to any small gap, but the remaining part is bigger. But in your design, I saw that it is more or less the same. Like the width is.
If it is there, then
Yes, good observation. Yes, the front doesn't come in; it has the same width.
And also because of that, the other three-wheelers, they have to turn a little bit to see the back. But in your one, it's not the case. So I think the design is good. And also, I prefer to have doors also, so that the dust won't come in.
Yes, we have a design with those, but we haven't showed that yet. We need to finalize that.
Then Dr. Deopri is asking, is there anything that the ISL Engineering Council could do on government policy related to import of completed products by local business leaders versus local development of products related to taxation of component? I think we have to, in my personal opinion, I think we have to have a debate, discussion at the Engineering Council and ISL level. But what's your opinion, Dr. Beshan?
I think those bodies can do a big role in this, because there is no consolidation of all these players and taking one policy to the government to kind of get it approved. And I think if we can show that, then there'll be more chance of the government listening and making some notable changes.
Yeah,
sorry. I mean, I will just add to that question, because this is the eternal problem. Because once a long time back, I went to the micro factory, and those people, they think difficult it was for them to develop their car, and then eventually they turned into the normal practice of bring cars and put label and selling, right? Now managing business of lobbying, because the businesses, if they want to make money, and the businessmen are in politics, so politicians don't care. Listen, I mean, it's money that talks, right? So how I mean, listen, you can just make this for to sound of people, and to see how can be to the people who kind of like the decision makers in the government and so on, because it really matters. Don't you think so? Please. Yeah, that's my question. I mean, how do you do this? I mean, can you find a way forward for this, please? Thanks.
Yeah,
Thanks,
it's very frustrating, isn't
important,
it? I mean, there's nobody to listen and really take some action, and I really don't know the way forward, to be honest.
So most of the participants today, I think they are members of ISL, and I think we better lobby and then push the management to
that's important.
Have a discussion. Yes, and then the other question is, I think it's a comment like, for example, a country like Norway, their 98% energy is from renewable, and the biggest use of Nissan Leaf. I mean, if you could invest simultaneously on renewable, the industry synergy will be high. Right, so it's a comment.
Very true.
Then there's another question from Dr. Apre. Is there any commercial value in the hydrogen fuel cell related development? Have you thought about this? Or this is
we have done some brief studies on the hydrogen side, and some of the pilots that were done by I think Honda in California is also now stopped. So we don't really see, the what the industry is kind of moving in that direction, and to be honest, so we haven't really spent a lot of time on this.
Okay.
Sorry, again related to that, and can I ask a technical question? Is it related to the cost or the safety? Hydrogen storage.
Yeah, I have read on the cost. I mean, on the safety side. So the hydrogen tanks that they had built were much more safer than the
6,000 bars and so on, right?
Yeah. So I think it's mostly on
the
cost of.
I will tell you one thing. Sorry. I have heard. In department chemistry, one of them has come out with a method of generating hydro using electricity. That kind of story, right? I mean, listen. I know this man. I mean, you can talk to these people. Have you? I mean, since you have given up that idea, I mean, at least you can be aware of these possibilities. But it's generated in that form. How do you pressure it up? Because you have to under pressure and so on. Given up this kind of thing, or you want to? I mean, you want to still talk about it, then you can get in touch with people in the department of chemistry, if you like, right? So this is again the telling you that there are other avenues available.
No, that'll be interesting. Yeah.
Yeah, and Dr. Beshan from Dr. Apre again asking, does fast charge affect the battery life also? What is your experience with your own battery?
With your own battery.
Yes.
Fast charging does
your own
have,
battery, right?
Yeah. Fast charging does have an effect on the battery pack. Fast charging, the quality of the BMS and the advanced capabilities of it really matters when you do fast charging, because you need to control the currents and voltages and provide thermal protection and things like that. But if you fast charge every day, there is an effect on the battery pack, that is for sure. But if you have advanced electronics on board, right? Then you can control the amount of issues that you can see.
No, it's a matter of getting the vehicle charged within half an hour or 1 hour, because you are in a hurry. You can't get stuck in a place for 3 hours to get your car charged, right?
Yeah.
So that's a very so now people are not very open about this kind of of the battery due to fast charge. So say it because they just want to sell. So I mean, because now you are not in that business, can certainly be. I mean, Leaf and all people keep on saying that you know, and you ask about this. Sorry, I mean, how much? What percentage? How much does it get reduced the lifetime if you keep on doing it regularly? That's a pertinent question.
Those are very difficult to say. Actually, more than the fast charging, what affects the lifetime is the amount, the temperature rise. So if your vehicle is driven on hot roads for a long time, then that has more effect on the battery pack than the number of times that you fast charge also. So those factors all matter. So it's difficult to say that if you fast charge 100 times, it would be this versus that.
Okay, thank you. And it's always the trade-off, and the consumers know about the issues, and also battery management system manage it. I think reduce the effect, right?
That's right. Yes.
And Professor Ilant is asking, at Vega Innovation, you work with a lot of young engineers with relatively low experience. But when we see the things that you have produced, we don't see there are any issues with that. Is that really the case, or do you have an internal arrangement to handle it?
No, I mean, this is the silver lining of all of this. Our graduates can do amazing things. I mean, people complain about our education system and all of that, but when these guys go to America and work at Intel or at Facebook or other companies, they are the best.
Yeah,
there is no other second word. They are the best. If I work for Intel in the US. When we hired people, we mostly hired Sri Lankans, Indians, Pakistanis, Chinese, because they know the technicalities, they know the theories and practicals and all of that much better than all of the other people. So it's really how you manage these youngsters to get the best out of them is where the the two different is. And I think our graduates are good enough to do amazing work, and I hope Vega is an example of showing that.
Okay, thank you very much. And then that shows that we have a lot of potential to
yes,
kind
absolutely,
of
absolutely.
And Engineer Kanchana Senadhir is raising his hand. Engineer Kanchana.
Thank you, sir. Dr. Bishan, it's nice talking to you. I was just wondering, when I was listening to how the tuk-tuk would operate in an urban environment, you would do some capping on the top speed and all. So to do that, you have to keep track of the position and the speed of the tuk-tuk. Basically, that will end up having to do some identity preserved in your AI related platform, the servers and everywhere. So in a case like that, how would you manage the inherent privacy issues? I mean, I know that Sri Lanka is not very concerned about it at the moment, but one way or the other, as we are to think about moving towards countries like Europe and all, we have to obviously start worrying about that. So how would you deal with such a problem?
Excellent question. Excellent. So I think this is where again policies should be there. If you want to control, how three-wheelers are driven in Colombo or Kandy or any urban area, then those policies should be listed out saying these are the restrictions. And if data is captured from the vehicle through IoTs, then what is the privacy safeguards? Are you really keeping individual data, or is it just the vehicle data? And yes, all of these things will matter. Of course, any data that we will capture, or if it's even on board, the customers will have to give consent. So we will give those privileges to the customer. And for example, Podgen company and all of the subsidiaries like Vega and ChargeNet, we all adhere to the European GDPR practices of data privacy. So it's a very stringent data privacy that they have. You can't really store even a phone number or a name or any things like that. So we will adhere to those standards for sure.
Thanks, Dr.
Okay,
Bishan.
thank you very much. Is there any other question?
I got one more. Is it okay, sir?
Yeah, go ahead. Yeah. So we have 1 minute. Yeah.
Yeah. When I looked at the the sourcing of the raw materials, I was just wondering how much of the what percentage of the raw materials that are being employed, that are being used, are from Sri Lanka, and how much of them that we have to source from the outside. I mean, the other countries. Because from my point of view, if we have to get them down from other countries at a very high cost, then again, we wouldn't have that much of an advantage of, when it comes to cost of production, right?
Yeah, this is a very sensitive question. I was asked about this also as to what really, why when would you say it's made in Sri Lanka? So this is a very, if you take the whole, the global supply chain right now, if you take a US vehicle or a Chinese vehicle or a German vehicle, components come from every part of the world. And to say it's made in Germany, what does it mean? Is it assembled there or designed there, or so it's a very I don't have a clear answer for it, but for sure we want to have about 80% of the value in Sri Lanka and to bring in the rest. If you look at Sri Lanka, we really don't have that many options, even the metal, the steel, all of that has to be brought in. We really don't have that much natural resources that, although we like to harp on it, we have to bring in everything, the plastics and all of that. So it's a very difficult game to play, and you're right, the cost will increase. So to balance all of that is very important.
Okay, thank you, Engineer Kanchan. And one last question. Now, this is about your company. I don't know whether you have the liberty to answer this. How do you manage with paychecks of top engineering graduates when you have to continue for 15 years without too much turnover in terms of salaries, sales? Is it diversification of your business that helped?
Very good question. This is a very difficult one to play. So our CEO Harsha Subasinghe, CEO of Cogen, has been pushing technology development and R&D in Sri Lanka. So all credit goes to him for paying our salaries for this long without a big business plan. And yes, the latter part of the question is exactly right. Diversification, and to see how our technologies can be taken to the market with different products. So we have been really trying to think about that to take our products out there, and taking ChargeNet, the EV chargers, to the Indian market is one good example of it. Because if that works, their tenders are for about 10,000 EV chargers at once. Apivage, they are not saying 3 chargers at once. They will want 10,000 chargers. So you have to really get into manufacturing and really have the potential to bring that income. So a lot depends on what happens in the future. And I think we believe as a company, we are developing a lot of IP and a lot of value from that end, so that at some point all of this will generate a lot more revenue than what we are putting in right now.
Is that related to my question, Kamal? Yeah. Sorry. Can I just, because you should not be shy of making investments in kind of sales and that kind of normal businesses. You have to keep on paying your pay, the engineers, right? So in that we need everything in this country and all kinds of things that don't do, right? Because we get quality material, you have to import, and again you have to generate money using other, you can buy and sell. That also should be there. Otherwise you can't survive, right?
Yeah. I mean, excellent point. We as a culture,
I know, because I'm telling you, you can't survive, right?
Dr. Deyapre, your line is breaking. Hello?
I wanted to further people this kind of thing. He were hell-bent only engineer, and eventually down the drain because they want to do things that we don't consider as respectable. I mean, you have to diversify. I think that is what you are doing, Dr. Beshan, right? Otherwise you can't survive, right? Because I think
that's right. Yes. So I mean, diversification is key, and you're right. We are not really good at buying and selling, at least within Vega. We feel that it's a very what's the word, like a low thing for us to do because we develop things. I think that that kind of a mindset is also not good. So we also need to improve on that end, because at the end of the day, you have to make it a business also.
Okay, thank you, for the question and the answer. And I think there are more questions coming, so I think we better stop now in the interest of time. Now, as the last comment, Engineer Sister Jama is asking, commenting, thank you, PEFAA, for all arranging this meeting. It shows there are many areas we can think of. It's a comment, general comment. And I wish more of our engineering faculty products follow Vega and have their own startup, not depend on the employment from government. So good luck for all success for Vega. So it's a comment. And it's really interesting discussion we had, and there are more comments coming, and I think we can direct if there is any specific question from Dr. Beshan. So I had a question. I just want to know whether your control systems, they are distributed controls or hardwired, but I don't think it's you can quickly comment, you can answer, otherwise
yeah, it is mostly distributed because if we want to sell these components individually on the automotive market, then they have to have their own control system. So it's mostly distributed.
Okay, thank you. So that was the one.
So can I ask a question related to that? Do you use CAN bus, or do you think in terms of flex tray and that kind of thing?
We use CAN bus and the LIN based.
LIN is the very basic thing. No, why don't you think in terms of flex tray?
Not yet, not for our applications yet.
Yeah, no, the LIN is the most basic one. No?
That's
so
right.
You are not even into CAN. Are you into CAN control or what?
Yeah, we use CAN buses. Yes.
Okay.
Okay. Thank you very much, and for all the questions and positively and contributing to the discussion. And thank you very much, Dr. Beshan, for giving your time to have this discussion. So I will hand over the session to Dr. Samita Buddhiga. Thank you very much, Dr. Beshan, for your discussion.
Thank you very much. My pleasure.
Thank you very much, sir. It is indeed a very satisfying evening with Dr. Beshan. The audience had so many different questions on different areas. I was carefully listening, and at the end, I would like to share one of my story when I went to postgraduate studies maybe 10 years back to Japan. When somebody came and asked, what do you make in your country? So I was confused and I thought about maybe a few seconds, and the only question, the answer that came out of my mouth is tea. So I think in the future, I think very soon, I'm very much confident that Vega will make Sri Lanka, as a Sri Lankan company, our youngsters and our nation's pride by developing this and making reality this Vega supercar, so that people can go out and tell that we have this kind of technology to others with a great pride. Thank you, Dr. Beshan, for your great work at Vega Innovations. And to deliver a vote of thanks, I would like to kindly invite Dr. Shobha Herath, the General Secretary of PEFAA. Dear Madam, over to you.
Thank you very much, Dr. Samit Buddhika. As today's speaker dedicated the talk to late Professor Jayatilaka, so I chose this backdrop. First thing, before delivering the vote of thanks, it was very nice presentation and very interesting. Lot of questions came. So I would like to invite Dr. Beshan to collaborate with us to do multidisciplinary research with University of Peradeniya. You can, PEFAA can help you connect to other faculties as well. Our faculty, of course, Professor Nilantha Samaranayaka is heading the Technology Innovation Center, so he can connect you to more research work and incubation, startup projects, etc. And then also we can help you to connect with other faculties, medicine, science, etc. as suggested, to do more innovations. Okay, and then before delivering the vote of thanks, I want to make few announcements. One is about next talk. So this is our next speaker. Actually, now we were having 3 talks, one about agriculture, fertilizer problem, and then about economy, and then about innovations. But none of these will be possible if we don't fight this COVID-19 and how to plan our future. So we thought of going in that line, and it's actually PEFAA Talk number 4, not 3. I made a mistake here. PEFAA Talk number 3 is planning the future with COVID-19 on 18th September 2021 at 3 p.m. by none other than Dr. Ananda Vijayvikrama, who is the senior consultant physician at IDH, the Infectious Disease Hospital, now known as National Institute of Infectious Diseases. And he is the one who fights to treat all the COVID-19 patients, critical patients at IDH. And he is seen on TV doing many discussions, educating people. So he's willing to talk with us and discuss how to plan the future at our organizations and engineering field. So I invite all of you to share this news with your friends and colleagues, and we will distribute the poster very soon. So I invite you to join on 18th. And then also I invite, if you are not still a member, from all of our graduates, Peradeniya Engineering faculty graduates, if you are still not a member, contact us and get the membership. Okay, now to the vote of thanks. Okay, so it is an honor for me to deliver the vote of thanks today at this public event organized by PEFAA with distinguished guests at the audience. So first of all, I would like to thank our speaker, Dr. Beshan Kulapala, the Managing Director of Vega Innovations, for accepting our invitation despite a very short notice and delivering this very inspiring talk on their story of product innovations. I'm sure all of you have gone through a journey of innovations with him. Actually, it was seen from the discussion, so we could not even stop the discussion on time. So thank you very much, Dr. Beshan Kulapala, for your dedication and spending valuable time with us. And then I wish to thank Dr. Lilantha Samaranayaka, Director, PTIC, Engineering Technology Incubation Center, for introducing our speaker today. And I must also thank Dr. Kamalnath Samarakon, Head Department of Computer Engineering, for conducting that very interesting discussion with Dr. Kulapala. So you took all the questions and got answers from him. So as always, you dedicate all your time on PEFAA work as well as the faculty work. So thank you very much, Dr. Samarakon. And then it was, I should thank to my teacher, Engineer Sarath Seniratna. It was great to listen to you talking about our great teacher, Professor Jayatilaka. And then I must also thank POTV, Event TV Plus channel for giving us airtime and telecasting this for people, and that enables us to reach all the members as well as general public. Next, my sincere thanks goes to our members who joined the meeting through Zoom and participated in the discussion, without whom this event would not be a success. and also to all the people who joined this very interesting talk. Last but not least, I thank to the Executive Committee of PEFAA for the support given, especially to Dr. Samit Buddhika and Dr. Damayanti Herat for organizing all the technical stuff behind the screen. Thank you very much. Have a good day.
Thank you very much.
Thank you very much all.
Thanks.
Hope to see you in the next event. Thank you.